So we're gonna continue the integration by substitution. So for number 8, you like to integrate of x squared plus 4x over x cubed plus 6x squared minus 10 dx. So for this one, you see that the bottom guy is more difficult than the top guy, okay? And you not see any parentheses at all, so you should let the bottom to be u in this case. So you're gonna let u to be the bottom guy, gonna let u to be the bottom guy, and you have du equal to 3x squared plus 12x dx. Okay, so you just differentiate, so you get 3x squared plus 12x dx. So you get 3 and you have x squared plus 4x dx. And you see that you see x squared plus 4x dx. Hey, this is exactly the same term. Okay, so this will be your yellow guy. So you're gonna just solve du over 3 equal to the yellow guy. Okay, so please notice something like this. It's gonna make your calculation a lot easier. And so the substitution that you're gonna use is gonna be, it's gonna turn out to be intricate. Okay, the yellow guy turned out to be du over 3, and the blue guy turned out to be u. Okay, so this one turned out to be 1 over u, and you have du. Okay, so you see that it's quite simple. The yellow guy changed to du. I forgot number 3. So it's going to be du over 3. Okay, and you have 1 over u. So for this one, it's going to be 1/3 log absolute u plus c. Okay, so it's going to be 1/3 log absolute x cubed plus 6x squared minus 10 plus c, and this one will be your u. Okay, so you have log u. Okay, so that the integration by substitution. So let me continue with number 9. Number 9 is going to be integrate of 1 over x log x dx. So you see on the bottom that is going to be product between two functions. One function is x and one function is log x. So you may think that, hey, can we just let u to be the bottom guy? Okay, so if you let u to be x log x, and you see that when you compute the u, it seems complicated because this one is product. So you must apply the product rule. So it's going to be the first derivative of the second plus the second derivative of the first. And it's going to turn out to make the function to be more complicated. Okay, so this one turned out to be more complicated. So it's not going to be correct. Okay, so this one is kind of wrong. Okay, so you're going to just pick one to be u in this case. So I would let u to be just log x. Okay, so I let u to be log x, and I have du equal to 1 over x dx. How would I know that I'm gonna let u to be log x? Because this one is kind of easy. Because if you let u to be x, nothing new. So everything turned out to be 1 over u log u du, right? So nothing gonna be. So you just change the variable from x to u, and it's not gonna change the difficulty of the question. So in this case, you let u to be log x, So you get du equal to 1 over x dx. So in this case, you would get integrate 1 over u and dx over x turn out to be du. Okay, so it's going to be du and this one will be 1 over u. So you would get log absolute u. Okay, so you would get log absolute u. Don't forget to plus c. And this guy turned out to be log of log x plus c. Okay, and this one will be your final answer. Okay, so you have u and you have log u. Okay, okay, so that's all for this one. It's still difficult, but it's actually easy. The next one you have 10x. Okay, so you have 10x. So for 10x, we not be able to integrate 10x directly. So we're gonna change into sine x over cosine x. Okay, so we're gonna change into sine x over cosine x. We did this one once, right? We did cot x before. Okay, so let's go back to cot x. So for cot x, you change into cos over sine. And in this case, you let u to be the bottom guy. Okay. So why you let u to be the bottom guy in this case? I have to say because it's working. Okay. So you let u to be the bottom guy, u equal to sine, and you be able to get rid of the top guy nicely in terms of du. So we're gonna follow the same trick. So we're gonna let u to be the bottom guy. So I would let u to be cos x. Okay, so I let u to be cos x and I compute du. It's going to be dip cos, it's going to be negative sine x dx. And this integral turned out to be, you see, it's going to be negative du equal to the yellow guy sine x dx. Okay, so you have the yellow guy is equal to negative du. And you have cosine x on the bottom. So over u and this guy will be negative du. Okay. And this one will be negative log absolute u. Okay. So it's going to be log absolute u. Don't forget to plus c. Okay. And this guy will be negative log of absolute cosine x plus c. So you're going to integrate tan equal to negative log absolute cosine x plus c. However, mathematicians not memorize this thing in terms of negative log cosine. We're gonna move the negative one to cosine. So this guy will be log absolute cos x to the negative one plus c. So you get log of absolute 1 over cos x plus c. So it's going to be log absolute secant x plus c. Okay. And then you get, okay, this one will be the thing that we gonna use. So this one will be our integrate tan x dx. So you integrate tan x dx is turned out to be equal to log absolute secant x plus c. Okay, so that will be this one. The next two will be the same criterion. So you have integrate sec and integrate cosec. Okay, integrate sec and integrate cosec not gonna be used the identity sec equal to 1 over cos. It's not gonna happen that way. Sec equal to 1 over cos it is correct, but we're not gonna integrate sec x dx by just change into 1 over cos and let u to be cos or something. It's not happen that way. The thing that we're gonna do for integrate secant is kind of tricky. Okay, so we're gonna do multiplication by a special term. So this guy, let me change the color. So this guy will be integrate sec x. Okay, and I'm gonna multiply sec x by sec x plus 10x on top, and you divide by sec x plus 10x on the bottom, and you have dx. Okay, so you multiply the top by sec x plus 10x, and you multiply the bottom by sec x plus 10x. So basically you multiply by 1, and the thing that you see will be this guy. Okay, turned out to be, you see the top, let me multiply. So it's going to be secant square x plus secant x 10x. Okay, and you have the bottom guy is just secant x plus 10x. So the top one is going to be just secant x 10x, and the bottom one is secant x plus 10x, and the top one is kind of complicated one. Okay, however, in this case we're gonna let you to be the bottom one. Okay, so I would let you to be just secant x plus 10x. And amazingly, you're gonna compute du, and the du turned out to be exactly the same as the top one. So you dipsec, you get secant x 10x. Okay, and you dip 10, you get secant square, and this guy will be dx. Okay, so you get du equal to secant x 10x plus secant square x dx. So this one, you see, turn out to be du on top and turn out to be u on the bottom. Okay, so everything kind of nice. Okay, and you gonna just integrate this one out. So you integrate 1 over u du, so you get log absolute u plus c. So in this case, it's gonna be log absolute secant x plus 10x. Okay, and you're gonna plus it. Okay, so this is the integration by substitution that you have. Yeah, okay. The next one is similar to the previous one, but for this one it's going to be cosec instead. So when you have cosec, you're gonna multiply by, okay, so you're gonna multiply by the kind of similar one. So we're not gonna multiply by sec plus 10 because cosec not gonna involve sec and tan. So cosec will involve cosec cot instead. Okay, and the trick part turned out to be you need to multiply by the correct side. So this one is gonna be you're gonna multiply by cosec x minus cotan x. Okay, so you're gonna multiply by cosec x minus cotan x. Okay, and for this one, you're gonna see that you multiply this guy on top, you're gonna divide by, okay, so you're gonna divide by cosec x minus cotan x. And for this one, you see that if you multiply the top part, you get cosec square x minus cosec x cotan x. Okay, and you have everything over cosec x minus cot x dx. Okay, so this is the one that we have, and then I'm gonna let you to be the bottom. Okay, like we have in the previous example. So you have cosec x minus cot x. So you compute du, okay? So you dip cosec, you get negative cosec x cot x, okay? You dip cot, it's gonna be negative, it's gonna be positive cosec square x dx, okay? So you get negative cosec x cot x for dip cosec, and you dip cot is gonna be negative cosec square, so it's going to be negative, negative become positive. And you see that this guy is exactly the same as cosec square x minus cosec x cotan x dx, and this guy turned out to be your du, exactly the same as the top guy. So this will be, let me move this term so it's not gonna in the way, okay? So you have this one, and you see pretty clear that this guy turned out to be du over, okay? And you have cosec x minus cotan x is going to be u. So this one is equal to log absolute u, okay, plus c. So in this case, going to be log absolute cosec x minus cotan x, and then u plus c. Okay. So this is the integrate cosec. Okay, so we have integrate sec and integrate cosec on this page. Okay, so and the way to compute integrate sec and integrate cosec kind of like I'm not gonna say difficult, it's gonna just tricky. Okay, so you need to multiply by the correct term. Okay, and this one kind of tricky to integrate. Okay, we're gonna derive another formula for integrate cosec later also. Ah, so we conclude another set of integral that we gonna have without proving it. Okay, so we already proved 4 of this formula already. So in this case, I'm gonna conclude that we be able to just memorize this thing, integrate tan equal to log absolute secant, integrate cot is gonna be log absolute psi, integrate sec is gonna be log absolute sec plus tan, and integrate cosec is log absolute cosec minus cotan x plus c. Okay, so this one will be another 4 formula for integrate of trigonometric function. The next one is going to be you like to integrate, okay, the function in the form of 1 over square root 1 minus u square, and you're going to integrate function in terms of 1 over 1 plus u square, and another one will be u times square root u square plus 1. So I'm gonna emphasize this one is gonna be the thing that you must see will be, I'm not gonna highlight it, I'm gonna write it down. So the thing that you see is gonna be you see 1 minus u square in this case. And you see 1 plus u square. Okay, so when you see 1 plus u square, you think about arctan. When you see 1 minus u square, you think about arc sine. And when you see u square minus 1, you think about arc secant. Okay, so you think about arc secant. So this is what you should think. Let me show you the formula together with this question. So the thing that you see here is going to be, you see the structure of the integral that you are having. So you see this guy is square root, okay, and it's going to be 1 of 4 x squared. So for this guy, you see that this guy can be written as, okay, so this guy can be written as integrate 1 over square root 1 minus 2x squared. Okay, so you see that we be able to write this term in the form So we'll be able to write this term in the form of 2x squared, and you have this guy and you have dx. So you see that it's gonna be square root 1 minus 4x squared, and it's gonna be 1 minus 2 2x and then square like this. So in this case you see 1 minus 2x squared, and so u equal to 2x. Okay, so this is, you have to see the structure. Like I said, it's going to be the structure that you must notice. The next one will be, you see this guy 9 plus x squared. So we have 1 plus u squared, right? So we would have 1 plus u squared. So in this case, you're going to pull out 9. So it's going to be 1 plus x squared over 9. So it's going to be 9. And it's going to be 1 plus x over 3 square. Okay, so it's going to be 1 plus x over 3 square. Okay, so this is what you see. Okay, so this is what you see. So in this case, you must be x over 3. Okay, so you just see the structure of the function. This is the thing that I like to teach you. The next one, let's do the next one first before I move to the other question. So for this one, it's going to be 1 over. And you see that the thing that you see here, is going to be 16x squared minus 1. Okay, so you see 16x squared minus 1, and this guy can be written as 4x squared minus 1. And so you're gonna let u to be 4x. Okay, so this one is equal to u squared minus 1, and you would let u to be 4x. Okay, so this is how we determine u. Okay, so it's not going to be u to be the whole thing. Okay, it's not going to happen that way, that u equal to 16x squared minus 1. Oh, not happen that way. Okay, so you have to look at the structure of the function. Well, let's do these 3 examples first before I go to the last question for 16. So for this one, you're gonna let u to be 2x. Okay, so you let u to be 2x. So you let u to be 2x. So you get du equal to 2 dx. Okay, so du equal to 2 dx. So the integral turned out to be, let me write this one, 1 minus 2x squared dx. So it's going to be integrate 1 over square root. Okay, so it's going to be 1 minus u squared, and du equal to 2 dx. So you would want to have dx. So dx turned out to be du over 2. So it's going to be du over 2 for dx. Okay, and for this guy, it's going to be negative. So it's going to be 1/2 and integrate 1 over square root 1 minus u squared du. Okay, and I want you to see the previous page. Okay, so you see that this is exactly the formula that we are having. Okay, so you have integral of 1 over 1 minus u squared du is going to give you arcsine u, then arcsine u. So this guy will be just 1/2 arcsine u. You see, so it's going to be easy. And what is u? What is u? U is equal to 2x. Okay, so what is u? U is equal to 2x. So it's going to be 1/2 arcsine 2x plus c. Okay, so this will be the key idea for this one. Okay, so that's it for this question. For number 14, you see that you must write the bottom guy. Okay, so the bottom guy turned out to be 9, 1 plus x over 3 square. Okay, dx. And this guy turned out to be, you see that I can pull out 1 9 outside, and you're gonna have 1 over 1 plus u square. Okay, so you need to know what will be for dx, so you need to differentiate. Okay, so you need to differentiate this guy. So you have du equal to 1/3 dx, right? So you would get dx, this term, equal to 3 du. Okay, so you have dx equal to 3 du. So 3 will be outside, and you are having integrate du over 1 plus u square. Okay, and this guy will be over 9. So you get, okay, 1/3, okay, and you integrate 1 over u square, so it's going to be r tan u. Okay, I need to plus c, so I need to move this guy a little bit. So I need to plus c, so it's going to be r tan u plus c, and this one will be 1/3. Okay, and what is u? U is x over 3. So u is x over 3. So it's going to be 1/3. Okay, r tan x over 3 plus constancy. Okay, so this is how we answer it. Okay, for 15, okay, for 15, it's going to be 1 over x, so square root 16x squared minus 1. Okay, so in this case, you see that this guy is u equal to 4x, and you're gonna have du equal to 4 dx. Okay, so you get dx, okay, right? So you get dx, okay, and you're gonna have to have 4x, but in this case it's gonna be 1 over, and you're gonna need 4x, so you're gonna have, let me write x first. So for this one, let me make it darker. So it's gonna be 1 over x, so square root and 4x square minus 1. Okay, and you have dx. But you see the formula, you see that it's going to be u and u square, but you have only u square. Okay, so for this guy, it's not u and u square yet. It's going to be u equal to 4x, so you get 4x. Okay, now you need this 4x, so it's gonna be, you need to multiply by 4. Okay, so you're gonna multiply this guy by 4, and you're gonna multiply the top by 4 also. Okay, so this is how we do this one. And then what? So you multiply 4 on top and on the bottom. Let me change the color a little bit, so it's being confusing. So this one is 4. It's nicer. So you have 4 and 4. Okay, so we need u and u already, so we're gonna just see that, hey, why don't you multiply 4 with dx? Can we? Of course you can. So if you multiply 4 with dx like this, you see this guy can be grouped together, and you would obtain automatically du. Okay, it's quite nice. So for this one, you're gonna get integrate. Okay, so this is exactly the same term. Okay, so let me write down the equal sign. And the top guy turned out to be du the bottom guy turned out to be u root u square minus 1. Okay, and this guy will be arc sec u plus c. So you get arc sec of 4x plus c. Okay, so you get arc sec of 4x plus c, and that will be your final answer. Okay, last but not least, so you have for this one, so you have nothing to see, so you not have like a 4 to the x minus 1, and if you let u to be 4 to the x minus 1, you go nowhere basically. The thing that you choose notice will be, the thing that you see will be 4 to the x minus 1, and this guy can be written as 2 to the x. Okay, so this guy is going to be 2 to the 2x, right? And 4 is 2 to the 2x minus 1, and this guy will be 2 to the x square minus 1. Okay, so it's 2 to the x square minus 1. And so, okay, you get, and so you get u to be 2 to the x. Okay, so you get u to be 2 to the x. And you see that when you see u square minus 1, you're going to use the arcsec. Okay, so you're going to use the arcsec. So in this case, you're going to try to write this integral. Okay, so you're going to try to write this integral in terms of, okay, so you're going to try to write this integral in terms of this guy, so it's going to be 1, right, and over, and you see that this guy turned out to be u square minus 1, but we do need u here and we do need u here, so you just multiply u on top and u on the bottom. Okay, so you just need u up there, okay, and you have dx. Okay, so that will be just you multiply by u on top and multiply by u on the bottom in order to obtain. But we don't know about dx yet. Let's compute dx. So for this one, you compute du is going to be 2 to the x log 2, right? I have not enough space, so I have du equal to 2 to the x log 2 dx. Okay, so it seems nice, but you have to notice also that 2 to the x, okay, so this term is equal to what? So is equal to u, right? So this guy is going to be you solve for dx, you solve for dx. So you solve for dx is going to be du over 2 to the x log 2. Okay, so it's going to be dx equal to du over 2 to the x log 2. Let me write them down. So this guy will be u dx, gonna write it in terms of the red guy. So it's going to be u square minus 1, right this, and u dx will be du. Okay, so it's going to be du over 2 to the x log 2. Okay, so it's going to be 2 to the x log 2. And what is 2 to the x? 2 to the x is equal to u. Okay, so 2 to the x is equal to u. So the yellow guy will cancel each other. So this guy cancel, this guy cancel. Okay, so this one will be 1 over log 2 outside. Okay, and you see that it's gonna be integrate 1 over u square root u square minus 1 du. So you get 1 over log 2 arc sec u plus c. Okay, so you get 1 over log 2 arc sec 2 to the x plus 3. Okay, so this is how we answer. Okay, so this one is the second part of the integration by substitution. I taught you the log, okay, the substitution that make you the log function, and you be able to discover the formula for integrate tan, integrate sec, integrate cosec. The next one is going to be you integrating the function that has structure of inverse trigonometric function, arcsine, arctan, and arcsecant. Okay, so that will be two topics for this part. We're gonna have the final one for the integration by substitution that involving many algebra or algebraic trick that we gonna see later. Okay, so I think I'm gonna stop here for this clip.